Hello, everyone. Welcome back to the next section of Relations and Functions chapter and the concept of relations. Yes, when the word relations, when I'm telling you the word relations, what thought comes to my mind? What relation? Which relation? With whom? That idea comes to my mind. Is it not? Yes. So let us understand this concept of relations first before we go to the definition. First, I will give you one example. Let us understand what it is. Then I will give you the definition. Okay. Yes. So now here, suppose I have a set A. Suppose I have a set A and the elements of the set A are 1, 2 and the elements of set B are 2, 4. Okay. Now, let us explain the relations. Now, with whom? The relation is from the set A to the set B. That means the relation exists between the elements of the set A and the elements of the set B. Okay. Now, we have just learned how to find the cross product. Okay. Yes. So let us find this cross product. So what is A cross B? So A is having two elements. B is also having two elements. So how many elements should be there? How many ordered pairs should be there in A cross B? Is 4. Okay, so 2 into 2. So which are the ordered pairs we are going to find here? 1, 2, 1, 4, right? Then 2, 2, 2, 4. Correct? Okay, so now this much is clear to me how to find out the ordered pairs. Okay, how to find the cross product. That is clear. Now, suppose I define R is equal to set of all x comma y such that x is less than y for every x belongs to the set A and y belongs to the set B. So now for every ordered pairs means it is nothing but I have to check the cross product. So check in the cross product, this condition. So such ordered pairs should be there in R only if this condition is met. What is that condition? X should be less than Y. That means in an ordered pair, the first element should be less than the second element. So look into the first ordered pair, 1, 2. Is 1 less than 2? Yes. So that means it comes in R. So here I'm writing 1, 2. Next, go to the second ordered pair. 1, 4. Is 1 less than 4? Yes, it is. So even 1, 4 comes to inside that R, whatever using the definition. Next, go to the next ordered pair. 2, 2. Is 2 less than 2? No, 2 is equal to 2 but not less than 2. So 2, 2 I can't write. Now, next, go to the next ordered pair. 2, 4. Is 2 less than 4? Yes, and so 2, 4 also comes within this R. Okay, now look at R and look at A cross B. What idea comes to your mind? What thought comes to your mind which you have already learned in the previous chapter, set theory? Look at 1, 2. 1, 2 is there. 1, 4. 1, 4 is there. 2, 4 also is there. Now, are you getting a thought of the word subset? Yes. So recall the definition of the subset. What is subset? When we say a set A is a subset of B, when we say A is a subset of B, if every element of A is an element of B. So same way here, I can say R is a subset of A cross B. Now check whether it satisfies that subset definition. Every element of R, how is the element in R? Ordered pairs. So every ordered pair in R has to be present in the as an ordered pair in A cross B. Check whether it satisfies. 1, 2 is here. Yes, 1, 2 is also there. 1, 4 is there. 2, 4 is there. So it exactly satisfies the subset definition. So what can I infer from this? What conclusion I can get? I can say that relation is nothing but the subset of the cross product. Okay, and here we go to the definition of a relation. So what is the definition telling us? A relation R from a non-empty set A to a non-empty set B is a subset. So this understanding is very, very important. Is a subset of whom? Subset of the Cartesian product or the cross product A cross B. Okay, is the definition clear? So what is a relation now? Relation means what should come to my mind? Subset. Subset of whom? The cross product A cross B. Okay, yes. So look at few points here. Note. First one, the set of all. Now, whichever we had here, the set of all first elements in the ordered pairs in R. Okay, the set of all first elements in the ordered pairs in R has one name. What is the name for all the elements together as a set? The name is called domain of R. Okay, next, I will explain to you with the previous example, but let us go through this once more. The set of all second elements in the relation R is nothing but the range of R. So if I come to the previous example here, look at R over here. So which are the set of the first elements? 1, here it is 2. So this 1 comma 2, what is the name for that set of all first elements? Is called the domain. So domain is nothing but the domain of R is 1 comma 2. And what you learned, the set of all second elements of R is called the range of R. So what is range now? Who is the second element? 2 and 4. So 2 and 4 is the range of R. Okay. Yes. So now go to the third point. The whole set B is called the codomain of relation R. So come to this example once again. So if you see R, the set of first elements is called domain, set of second elements is called range, and the whole set B, second set, whole set, so that is called the codomain word. So what is codomain now? The full set 2, 4. Sometimes it can be equal to the range, or codomain may have some elements extra. Okay, so that we are going to solve in few examples. Okay, so now we have understood 3 terms. One is you have learned what is domain. What is domain? In R, in the ordered pairs, the set of all first elements is called the domain. In R, in the ordered pairs, the set of all second elements is called the range, and the whole set B, that is to find A cross B, A and B, no, second set will be given, full second set is called the codomain. Okay, yes. So now what is relation word? Relation word means what should come to my mind? I had told you subset. Subset word means what should come to my mind? 2 to the power n. So all these terms and logic is interconnected. So suppose n of A, that means number of elements in the set A is equal to P, number of elements in the set B is equal to Q, and number of elements in A cross B is equal to PQ. Then total number of relations. Total number of relation means what should come to my mind? Subset. Subset of whom? Cross product. So if A is having P element, B is having Q element, how many elements are there in the cross product? PQ. So then how many relations are possible? 2 to the power PQ. Hope this idea is clear to you. Yes? Okay. So let us go to the exercise problems now. Let us solve the second exercise, 2.2. Okay. Yes. So coming to exercise 2.2. So the first question over here, okay, the first question. So we have let A is equal to 1, 2, 3 up to 14. So there are 14 elements in the set A. Define a relation R from A to A. So A is having 14. Next set codomain also is having 14. So I have to define R using this definition. What is the definition? Set of all x comma y such that 3x minus y is equal to 0. Both x and y should belong to A. And the question in turn tells us write its domain, write its codomain, and write the range. Yes? So got the ideas? Let us begin. So here the answer is, now I have this, what is this condition telling us? 3x minus y is equal to 0 means y is equal to 3x. Okay, so give values for x such that you get the values of y. So first let us write what is r is equal to. First put x value as 1. So what is that you're going to get if x value is 1? 1 into 3. So y value is equal to 3. Next, so what is a condition to be kept in mind? Both the values should be there only from 1 to 14. It can't move outside that. Okay. Next, give x value as 2. So 2 into 3, you're getting 6 for y. Next, give 3. 3 3s are 9 you are getting. Next, give 4. You're getting 12. Now, suppose you give 5. What is that value you're getting for y? 15. Is 15 present in A? No, isn't it? So I can't include for x is equal to 5. So these are the only ordered pairs present for the given condition. Now, so one part of the answer is done. So you have to write the domain now. So therefore, the domain is equal to what we have learned just now. Who is the domain? Domain is set of all first elements of the ordered pairs of R. So who are the ordered pairs here? 1, 2, 3, and 4. So domain is 1, 2, 3, and a 4. Next, what is the range? Tell me, range is nothing but what is the range you have learned? The set of all second elements. So who are there in the second elements of R? 3, 6, 9, and 12. Next, codomain. So who is codomain? We have learned the entire whole set, second set. So who is the set now? It is from A to A only. So A set is only the codomain. So codomain is equal to A only. And who is that? 1, 2, 3 dot dot equal to, then the last element 14. Okay. Yes. Hope you have understood the first question. Yes. So we move on to the next question, the second one. What is given here in the second question? Define a relation R on the set N. Who is this N now? Natural numbers by x comma y, set of all x comma y such that y is equal to x plus 5. And x is a number, it's a natural number less than 4. This is very important. X is a natural number which is less than 4. So depict this relationship using roster form. So roster form and set builder form we have learned in the set theory chapter. So roster means what should come to my mind? Answer. So answer of the question is roster. Okay. Yes. So first let me find R, then let me go to the domain and the range. Okay. Yes. So let's come to the answer of this. So what is the condition given? I have to get all ordered pairs x and y such that y is equal to x plus 5. And who is x is equal to? Tell me. Natural number starts from 1. What is the condition on the natural number? X should be less than 4, not equal to 4, but less than 4. So which are the numbers x can take here? 1, 2, and 3 only. So substitute. So therefore, R is equal to, which is a first ordered pair. Take x as 1. So 1 plus 5, you're getting y as 6. So getting 1 comma 6 is your first ordered pair. Next, take x as 2. So 2 comma 7, this is the second ordered pair. Next, take x as 3. 3 comma 5. 3 plus 5 is how much? 8. So 3 comma 8 is your third ordered pair. Only this much. Okay. I hope this idea is clear. Be careful with less than 4. Don't include 4. If it was less than or equal to 4, then that 4 would have been included. So now this is my R relation. So how to write the domain now? So the domain here is nothing but the set of all first elements 1, 2, and 3. What is the range? Range is nothing but set of all second elements of R 6, 7, and 8. Is that clear? So suppose they ask us codomain. Here they have not asked. Suppose they ask us codomain. Then it is nothing but the set of all natural numbers. Okay, whole set. Hope the idea is clear. Yes, we move on to the next question. Question number 3. Now what is mentioned here? A set is 1, 2, 3, and 5. B set is 4, 6, and 9. I have to define a relation R from A to B by R is set of all ordered pairs such that the difference between x and y is an odd number. The difference between x and y is an odd number. I have to write it in roster form. So that means what I have to write? I have to write the answer. Okay. So what is a condition? Condition is I have to get all the ordered pairs x comma y such that the difference, okay, so the difference between x and y, so here the difference, let me write, should be a odd number. It should be a odd number. Now when the difference is word is mentioned, it doesn't mean that first number minus second number only. It is the biggest number minus the smallest number. That's it. Okay, so you have to take all possibilities where when you subtract you are going to get the difference answer as an odd number. Okay, so now what you have A set is 1, 2, 3 and 5. You have B set is 4, 6 and 9. So take one and pair with all the second set elements. If ever you're finding the difference an odd number, group it in R. Okay, so let us try. So R is equal to, let us start with 1 with 4. 4 minus 1, 3. So that is odd number. So 1 comma 4 comes inside R. Next 1 with 6. 6 minus 1, 5. Yes, it goes. So 1 comma 6. What about 1 comma 9? 9 minus 1 is 8, which is not even odd number. It is even number. So that does not come in our R. Okay, so leave one, go to the next one. So go with 2 to 4. No, even number. 2 to 6. 6 minus 2, 4. Not possible. 2 and 9. 9 minus 2 is 7, odd number. Yes, so 2 comma 9 comes into R. Next, 3 and 4. 4 minus 3 is 1. Yes, so that comes into R. 3 and 6. 6 minus 3 is 3. Yes, odd number again, so 3 comma 6 come. 3 comma 9. 9 minus 3 is 6, which is even number. That doesn't come. Okay, go to the next ordered pair. 5 and 4. 5 minus 4 is 1. Yes, it goes. 5 comma 4. What about 5 and 6? 6 minus 5 is 1. Odd number, so 5 and 6. What about 5 and 9? 9 minus 5 is 4, which is even number, so only these many. Okay, yes. Now suppose the domain was asked, what would be your answer? So let us write that domain and range. So domain is equal to set of all first elements, so 1, 2, 3 and a 5. What is range? Set of all second elements. So what is it? Nothing but I have 4, 6, 9. Okay, 4, 6 and 9. So this is my answer for third one. I hope the idea is clear to you all. Yes. We move on to the next question, fourth question. Determine the domain and range of the relation R. So that means I have to find the domain and I have to find the range of relation R defined by R is equal to set of all x comma x plus 5 such that x belongs to 0, 1, 2, 3, 4, 5. So I have to take all the elements of x, that is 0, 1, 2, 3, 4 and 5 and substitute there. So that would be my answer. Okay, yes. So let us start by substituting. So answer R is equal to, first substitute x as 0. So you will get 0 and 0 plus 5 is 5. So first ordered pair 0 comma 5. Next put x is 1. 1 plus 5 is 6. So you're getting 1 comma 6. Put x is 2. 2 plus 5 is 7. Okay, so 2 plus 5 is 7. Next 3 and 3 plus 5 is 8. Next 4. 4 plus 5 is 9. Next 5. 5 plus 5 is 10. So this is the relation R. Now in this relation, so check once 0, 1, 2, 3, 4, 5, 0, 1, 2, 3, 4, 5, all the x values you have put there. Okay, yes. So what is the domain here now? So the domain is nothing but the set of all first elements. So what are the first elements? 0, 1, 2, 3, 4 and 5. Okay, what is the range you have got? What is range? Range is nothing but the set of all second elements. So what is it? 5, 6, 7, 8, 9 and a 10. Okay, so I hope this idea is clear of domain and range and how to write the relation. Very simple and easy. Yes, we move on to the next question. Fifth question. What is this question telling us? Write the relation R, that is set of all x and x cube. So whatever x is written and x cube, such that x is a prime number less than 10. in roster form. That means I have to write the answer. First of all, before you write the answer, first to find out who is the prime number less than 10. 1 is neither prime nor composite. So 2 comes the prime number, 3, then 5, then 7. That's all. So my X value can be 2, 3, 5, and 7. This idea I should get from the question itself. Okay. Yes. So let us proceed with the answer. I have to write R is equal to X and X cube. So first to write X values. Okay. So X values are 2, 3, 5, and 7. So if X is 2, how much is 2 cube? This is equal to 8. So 2, 8 is coming as the first ordered pair. Next to put X as 3. How much is 3 cube? 3 3s are 9, 3s are 27. So 27 is the second ordered pair. Third one, 5, and 5 cube is 125. Then fourth one is 7, and 7 cube is 7 sevens are 49 into 7 is 343. Okay, so this is the relation R which I have to get as the answer. Now suppose this domain was asked. Let us write the domain and range. So what is the domain here? So domain is 2, 3, 5, 7, the set of all first elements of R. What is the range? Range is nothing but the set of all second elements of R. So 8, 27, 125, and a 343. Hope this idea is clear. Yes. We come to the last question of this exercise. Yes. So what is the sixth question? A is equal to X, Y, and Z. Okay, set of A is X, Y, Z. B is 1, 2. Question asked is find the number of relations. Find the number of relations. Okay, find the number of relations is asked. Yes. So number of relations means what? Relations means nothing but it is the subset of the cross product. Okay, so first check if the set A is having 3 elements. Okay, so here we are having the solution. How many elements are there in A? Number of elements is 3. Next, how many elements are there in B? That is equal to 2. So how many elements should be there in A cross B then? So number of elements in A cross B is 3 into 2. This has to be 6. But the question is, how many relations are possible from A to B? So therefore, number of relations. So number of relations from A to B. From A to B. What is relations? Nothing but it is a subset of the cross product. Subset means what should come to my mind? 2 to the power n. So number of relations is that is equal to 2 to the power. What is the number? 6. And how much is 2 to the power 6? It is equal to 64. So 64 relations are possible from A to B. I hope you have understood the concept of relations. Yes. Thank you.